Okay, the strategy that I would introduce to the students is a multiplication strategy using halving and doubling for grade 5. Um, so I would start by just sharing with them how cool it is to be able to multiply large numbers in your head just by a process called doubling and halving the numbers. And so I would go on the board and I would maybe throw out a large number like multiplication like this. Maybe 25 times 16 equals, and I try to get them to try to guess the number and just say, wouldn't it be cool if there was an easy way to do this in your head? And so I would share with them that if we double and half the equation, it's much easier to do mentally. And so I would share that whenever you double in half, you have to double in half each side. So one side would be doubled and one side would be halved. And in this case, it'd be easier to double this side to 50 and half this side to 8. So double 2 times 25 is 50, double that, and half the other side, because if you double one side, you gotta half the other side. And so half of 16 is 8. Now, I think we could probably stop there and get the answer just by suggesting you simply multiply 5 times 8, which is 40, and then carry your 0. But I'd like to share with them that you can continue with this just to give them a better understanding of halving and doubling and how it doesn't change the outcome if you continue. And so we're going to continue this by doubling the 50 to 100 and then multiplying the other side by half of this number. So half of 8 is 4. It gives you 400, which is a lot easier to do than even this or this. And so if this is 400, then this has to be 400, and this also has to be 400. But they would clearly see that by doubling and halving each side, the process gets a lot easier. It's a lot easier to multiply 4 times 100 than it is 25 times 16 in your head. And then I would share with them how this works, and I'd try to give them a manipulative, to give them a visual to make it a little bit easier to see. And so I would maybe do something like this. In this particular case, I'm using Jenga blocks, but anything works really, coins or, and so this I would demonstrate. I would get them to count them. There's how many? There's 12. And then I would turn that into a multiplication. So we have 4 in this row and 3 in this row. And so that's a multiplication of 4 times 3 equals 12. And so to give you a visual of what we just did over here, we would half this and double it. So we would half the rows of 4 and double the row of 2. Let's see if we're going to get the exact same answer. I'm going to twist this, and I know it's probably not going to work very well, but of course it does. And so we just halved and doubled, and that turned into this multiplication, which is 2 times 6, and we still have 12 blocks. And so then we could take it a step further, and we can double and half again. And so we would half these 2 rows in half, which would be, if we halved them, it would be 1 row of 12. So we half the 2 by half, which would be 1 row, and double so we would now we have 1 row of 12. And so it would look like this. We started out with 4 times 3 equals 12. And then we half that, 4 to 2, and double the 3 to 6, we still get 12. And then we continue by halving the 2 to 1 and doubling the 6 to 12, and it still equals 12. And so what I would do then is I would then get the students to try it with, varying multiples, just adding more blocks or taking away blocks so that they could, visualize the manipulatives and just keep trying with higher numbers and lower numbers, and they'd be able to see that halving and doubling makes it a whole lot easier to multiply in your head.